Okay, guys, welcome back to more math. You'll notice that I already have out my math book. And so if you read the instructions, you should already have your math book open to page 310 before you started the video. So if you don't, hit pause and go ahead and get that out. Okay, so today we want to talk more about using everything we've learned so far about the properties, commutative, associative, distributive specifically, and what does that have to do with equivalent expressions? We've talked about equivalent expressions, things that are equivalent or equal to each other. We got the math balance out, and we talked about, well, you can't really see my arms, but remember we practiced putting expressions on the balance and making sure that it stayed balanced. Whatever was on each side of the equal sign needed to be equivalent to each other, equal to each other in order for the scale to stay balanced. So expressions, again, are terms that don't have an equal sign, right? That would be any equation. So today we want to talk about how do we know if expressions are equivalent. So starting up here in your textbook, I'm going to zoom in a little bit on example 2. They're saying use the properties of operations to determine if the expressions are equivalent, the different properties that we've been practicing. So you'll notice that they have, and this is again, remember, I was going to say last week, but it's been 3 weeks ago that we were all together in class. I'm sorry. Last time we were all together in class, and I was showing you guys the way our book lists an expression, and then it uses a semicolon and lists the other expression, and it's really hard to see the semicolon. You just think this is one big long expression, but it's not. So this is one expression, and this is another expression, and they're asking, are those two expressions equivalent? So they rewrote it with an equal sign in between them. So now it's a little easier to see. Can you see that this expression they rewrote here, and this one they rewrote here, and they put an equal sign? And they're just, are they equal is the question. Are they equivalent? So with this one, anytime you see this in any expression from here on out in math, you know that you can use the distributive property to simplify this. So just like when we were simplifying fractions and we're like, do I need to simplify it? And we would always say, just keep simplifying it until you can't do anything else to it. Well, so you might say, how do I know if an expression is simplified? Well, if there's nothing else you can do to it, there is something I can do here. I can go ahead and take that 3 and kind of pour it in here and multiply each factor inside the parentheses by that 3 on the outside. So it's not simplified because I can still do something. So yeah, they didn't actually show you, but if I was going to go ahead, yeah, they did. They showed it over there. If I was going to go ahead and multiply this, 3 times x is 3x, minus 3 times 2 is 6. So you see that both of them are actually equivalent. And they did tell you that they are equivalent. But then down here, you've got this expression, 2 plus x, and then you have this other. This is simplified. There's nothing else I can do to it unless somebody tells me what x is. But this is not simplified. I can still do something to it. Okay, I can multiply 1/2 times 4. When I multiply 1/2, I'm sorry. Yeah. I don't like the way they wrote this. I'm going to write it out to the side. When I multiply 1/2 times 4, I get 2. Okay, plus 1/2 times 4 is 2, right? Because half of 4 is 2. Plus 1/2 times x gives me 1/2 x. So if I rewrite it to where my x is first, just because I can do that with the commutative property of addition, 1/2 x plus 2, that's the simplified expression. Is it equivalent to this one? No, because this is 1/2 4 plus x. So these are not equivalent. Okay, 2 plus x. I'm sorry, I said the wrong thing. 1/2 x plus 2 is not equivalent to 2 plus x. So these two are not equivalent. So anytime you see this factor form, because the numbers can still be factored and distributed, it's not simplified. This is simplified. I can't do anything else to it until I know what x is. So this is going to be probably the biggest thing that you're going to get hung up on is, have you taken it to its simplest form? Have you done everything you can possibly do? That's going to be the most common mistakes. So I want you to take a minute, and I want you to solve these two. And I'm going to ask you to do the same thing that they did up here in the example. use the properties of operation. So can I rearrange things? Mostly you're using the distributive property. You might be using the commutative to rearrange things to find out if this is equivalent to this. See the little semicolon there? Over here, the semicolon is harder to find. Is this equivalent to that? Okay, and then I want you to pause it and write out whatever work you need to, and then come back and we'll go over it. Okay, so I'm assuming you've done it. Is this simplified? There's really nothing else I can do here unless somebody tells me there's an x. I could work backwards from the distributive property, but I don't want to. I'm going to go ahead and leave it there because I'm going to go ahead and do the distributive property on this one. I'm going to do 2 times 3x and 2 times 5. Once I do that, 2 times 3x gives me 6x, minus 2 times 5 gives me 10. I can already see that these two are not equivalent. Okay, so you would write it out like this, that they are not equivalent. Okay, and then let's try this one over here. There's no distributive property I need to do, but this is pretty much simplified. I can't do anything to it. This is 5x. But on this side, 2 minus 2, that's just 0, isn't it? So they kind of cancel each other out. So all I have left over here is 5x. So these are equivalent, right? All right. So just that thought, that idea of trying to figure out if they are equivalent is going to be something that you're going to hear. Okay, so I am going to break this up into a couple little shorter videos. So before we go on to some new stuff, I want you to, we're going to put these notes in your math spiral. So I'm going to stop this video and start another one in a second. So when this is over, I want you to go and get your math spiral out and go ahead and make it look like this. Okay, equivalent expressions vocab. So it's in your book, but y'all aren't going to keep your book with you all the time. And in school we would put them in our binders, and then you guys would clean them out, and then you wouldn't have them. So these need to go in our math spiral. So we're going to put them in our math spiral, but I want you guys to, the reason I'm stopping the video is I want you guys to take a minute to get your math spiral out and find 3 different colors. Okay, this is going to be important. It can be highlighters, it can be coloring pencils, it can be, colored pens. A lot of you have a lot of color. I want you to have 3 different colors before we go any further. So I'm going to end this short video about just, are they equivalent? And let's see here. Oh, Miss Chapman's calling me. And then I will see you back in just a minute. All right, see you.